Hello guys, today we'll be deriving trig identities using complex numbers. It can't be a big trick using complex numbers, but just log in, it's not that difficult. So we use the Euler's formula, e to the power of ix, equaling cosine of x plus I sine x. And I got my cosine of x and sine of x by getting two of these and just solved for cosine and solved for sine. And yeah, let's begin with double angle identities. So first we have sine of 2x. This, because we changed the x value inside the brackets, we change the x value on the right side to 2x. Because we have 2x, I can take it out of the brackets to get e to the I x squared minus e to the power of minus I x squared. I use the binomial formula, which you should know, to get these two brackets. Then I substituted our sine values and cosine values from above and cancelled out the 2i to get sine of 2x equaling 2 sine x times cosine of x. And next we have cosine of 2x. We again change the x value to 2x and we take out the 2 out of the brackets. Use the binomial formula again to expand the brackets, and we cross multiply and substitute our cosine and sine values to get this monstrosity, but almost all of it cancels out. We divide by 2 and get 2 cosine squared of x minus 1. Next up are product to sum identities. We start with cosine of a times cosine of b. We have our two different cosines divided by 2. So we just multiply them inside of brackets, don't forget the brackets. And we expand the brackets to all of this, and we substitute the values for cosine and get that cosine of a times cosine of b equals to 1/2 times cosine of a plus b plus cosine of a minus b. Next up is sine of a times sine of b. We basically have the same, just on a different denominator. And don't forget the brackets, and we expand the brackets and multiply both denominators. So we have e to the power of I times a plus b, and as you can see, the rest all over minus 4. We substitute our cosine values again, and because we subtract because of the signs, we change the plus to a minus inside of the identity, and we get that sine of a times sine of b equals 1/2 times cosine of a minus b minus cosine of a plus b. Now the last one is sine of a times cosine of b, or it could be the other way around, it doesn't matter. So we have our two different complex values from above. We multiply them and expand the brackets, and we get all of this. We substitute our sine values to get all of this. 1/2 times sine of a plus b minus sine of a minus b. So yeah, that's where the trig identities that I derived. using complex numbers. They aren't that difficult, so you can do it too.